Hello there. Okay, so I received a question about this problem or problems like it in my math lab, and so I thought I'd help you out with using StatCrunch to find a lot of these values. Okay, so we have a survey of, oh, actually, I'm going to do the example, but it's going to work very similar to your problems. It's technically number 33 in the study plan that I'm doing, but there are several problems in the homework that'll show up like this. So okay, so it's a dependent sample. You can tell that because they're asking the same people two questions, right? So they ask one person two different things. It's dependent, right? And then is it, significant difference? Well, that means you're asking a two-tailed test. So this one's a two-tailed test. All right, so then we have our thing up here, and we need to find the test statistic, the z-score. Now remember from your inferential statistics cheat sheet, this is on page 6. This is when you're testing the difference between proportions for a dependent sample. It's called McNemar's test. All right, so we've got all this beginning stuff. We figured out our hypotheses. Life is grand. So we're sitting here trying to find the test statistics. So we need the absolute value of f12 minus f21 minus 1 over the square root of blah, blah, blah. Now, this is not done in StatCrunch or Excel. They don't do this test. So we're just going to use a calculator to kind of help ourselves out here. So we need to take the absolute value of f12 minus f21. And let me bring up a sheet of paper here. There it is. Okay, so there's the formula. Now if I go back, I gotta find it right there. Okay, so remember that the order goes 1, 1, 1, 2, 2, 1, 2, 2. And I have that right on the inferential statistics sheet. It's not something you have to memorize. That is always the order these go in because they're always these little two-way tables. So 1, 2 is always this top left, or excuse me, top right corner, and 2, 1 is always this bottom left. So for our problem, let me see, we got to take 423 and 355. So I'm going to take let me copy and paste this a little bit. All right, I'm going to take 423, take away 355. I'm going to do it down here, 423 plus 355. And of course, I'm going to use a calculator, and you just need a basic one to help yourself out here. This is just the absolute value, which means it's just going to be positive. So let's see here. If I take 423, take away 355, that's 68. 423 plus 355 is 778. So this is 68 take away 1 over the square root of 778. Okay. Technically, it's the absolute value of 68, but that just means that it's going to turn positive, and 68 is already positive. So I need 67 divided by the square root of 778. Actually, I'll find the square root of 778. Square root second square root 778 gives us about 27.893. Oh, and you could do this with Excel or whatever. It's I'm just glorified finding values here. All right, and then I need to take 67 divided by that. So 67 divided by that answer, second answer, gets about 2.402. And just for fun, let me bring this up. You could take equals, 423, take away 355, right? Take that away from 1, equals the square root of 423 plus 355. There's your other number, right? So I really want that, take away 1. Technically, you want the absolute value. You could take ABS, parentheses, of 423 minus 355, take away 1 like that. I don't know if you caught it, but that's what it is. Absolute value of 423, take away 355, take away 1. You close your parentheses and then take away 1. And then you take this number, 67, divided by that number. There you go, 2.402. All right, now I'm saying all this. Let's hope I worked it out right. So continue, continue, continue. Oh, look, 2.40, just like I said. Okay, so then we want the p-value. Okay, so the p-value, remember this is a normal curve, right? So I want the area in the tails past 2.402. Oops, let me bring this up. So I want the area past, I found this one on the right to be 2.402, which means that one over there is negative 2.402. And then I want those scores, right, off in the tails. So you can do this a couple ways. I mean, first you can do it with Excel. So I could say equals norm, well, actually 2 times, because I'm going to do one of them and then I'm just going to multiply it by 2. Dist And then my x value was 2, actually, that cell right there, 2.402, comma 0, comma 1, comma true. Oops, that's going to be the wrong way. Normdist always does left tail, right? So, oopsie. So I need to multiply. Oops. It's negative. There we go. Okay. The reason being because what I found originally, normdist with, here, let me show you. When I do normdist with 2.402, it finds all this area up to 2.402, which would be huge, right? So what I really want is this little bit in the tail. So if I do negative 2.402, that's my negative 83 right there, then that'll give it to me. You could also do it with a calculator. If you have this calculator, you can do norm CDF from 2.402 comma 1 E99 comma 0 comma 1, close your parentheses, enter. So that'll be one of them, 0.008, and then you times it by 2 because you need both of them because it's a two-tailed test. See, same thing, 0.1016. And with StatCrunch, which is my favorite, I would go to data, oh no, excuse me, stats, calculators. You want a normal calculator down here, normal. And then you're going to do mean is 0, standard deviation is 1, that's fine. You want 2.402, and you want, actually I'm going to do this wrong for a second. See, that was what I was finding before, that 0.99. I don't want that. I want greater than. So there it is, 0.008, and then because it's a two-tailed test, you just multiply it by 2, and you'll get 2.402. So that's another way to do it. But there is no actual test for this in the stats menu. It's not in here because McNamar's test is kind of this unique thing. Okay, so that's how to do it with StatCrunch, with Excel, and or the calculator, whatever you like. And of course, on your final exam, it'd probably be just looking at the output or something like that. Ooh, or actually, just on a side note, you could find it with the standard normal table too. Remember, we'd want the negative one because it's right here, negative 2.402, so it would round to negative 2.400 right there. Negative 2.40, it's 0.008, which is just what that found, 0.008, and you'd multiply it by 2. So you could actually use the table to do it as well if you had to. All right, so there's 4 different ways. I hope that helps. And then let me double check and make sure. Oh, see, I was right, 0.016, because you're multiplying 0.008 times 2. Cool. And then I'll have to decide probably to reject if our alpha level, alpha's 0.10, that p-value is lower than alpha. So of course we're going to reject the null hypothesis. All right, so that should help you. There's a whole bunch of them, not a whole bunch, but there's a couple of them like that in the homework, and they work on these same principles. All right, see you later.